Hey guys, it's Daniel Walker, and for my science experiment video, I am going to be showing the range equation. So I'm going to be basing off of OYO 4.7, and it says a rifle shoots its bullet with an initial speed of 2.00 times 10 to the second power feet per second. At what angle should a marksman aim his rifle to hit a target that is 5.00 times 10 to the 2 feet away at the same height as the rifle? So obviously I'm not going to be able to use an actual rifle and test the speed, so I'm going to be using a Nerf gun, and we have a chrono barrel which tracks the speed of the bullet coming out of the barrel, and I'll be able to know the initial speed of that, and then afterwards I will place it equal to the target. The rifle and the target are going to be equal. I'll use a measuring tape to do that, and I will be able to figure out what angle I will need to hit the target. Hey guys, so this is what we've got today. We've got the Nerf Strife. This is one of Samuel's favorite blasters, guns, whatever you want to call it. And we've got a mag of 6 bullets here. They're different types, but I made sure they're all pretty usable. And this thing right here is, I think it's called the chrono barrel, and it tests the accuracy, not the accuracy, the speed of the dart in FPS, feet per second. So pushing that on there like that, and I'm just going to show you guys how this thing works here. This is the on button here. Flick it over. Oops, that's the off button. There we go, like that. And so it should show you. So 38.8 FPS, and it says there's 5 rounds left in the mag. So that's how it works, and that's the speed that we got. So the next clip that I'll show y'all, we're going to test out 5 different bullets, and we're going to average those out, and then I'll do the equation later. But right here we've got the our little setup here. We couldn't go as many feet as the actual problem says, so we have 25 feet, if you can see that right there. And it goes all the way down to that end on the stool. And I'm going to take this off now because we don't need that. Down here, we've got our target that Samuel made like 3 years ago. And the stools are equal other than the carpet, which I could probably put something there, so I'll have that fixed. But yeah, obviously just shooting it straight is not going to have it hit the target because of gravity, so we're going to figure out what angle we need based off of the feet per second that we get of the average of the 5 darts that I'm shooting there. Okay, so I told you guys earlier, we've got target here and all this, and I told you that the tile is uneven to the carpet because there's a little bit of an incline when you get to the carpet, so I substituted some DVDs to make up for that. So now the stools are completely equal. So we're going to fire 5 rounds down range, if you want to call it that. And there's our doggy. We've got the bullets. We've got 6 bullets in the bag. And we turn on our chrono barrel here, and it says it's got 6 bullets in it. That's what we have. So I'm gonna fire these, and I've got this little thing to make it equal, so it doesn't, you know. Wait a minute. Yeah, just like that. All right. So obviously it's not gonna hit the target because there's this thing called gravity. But we're going to get a reading of how fast the darts are going, and then we will work out the equation in the next clip. Here we go. Oh my gosh, stop the video. Alright, so we had a failed attempt. The jam door got messed up with a bullet, but anyways, we're going to try to see if this works now. 59.9, 60, 61.2, 73.5, 76.0, 78.0, and that's it. So they all got progressively faster, which is interesting. And I think one of them actually hit the target. I'm not sure, so we'll have to check the video. But anyway, that's it for that clip. This is my third take of this, so hopefully it makes sense. We've got our 5 readings here for the speed of the darts. The average is 68.1. And then you have the range equation. Range equals V naught squared times the sine. And with the parentheses, 2 theta close parentheses divided by gravity. You plug in the numbers, and it looks like this jumbled mess. 25 feet, which is the range. That's the velocity. And sine, that stuff stays the same. And you've got your gravity here, 32 feet per second. So then you switch the equation around, so you're solving for theta, which is going to be our angle. And it looks like this. We've got these up here and these here. And I actually forgot to do this. So, so the second, because they're squared, where's the pen? Where's the pen? Oh, there it is. So that's going to cancel out with that. And then this is going to cancel out with that feet and that feet. So you're just left with a bunch of numbers plus the sine with the 2 and the theta. So you work that out, and you get this jumbled mess here. And I decided not to use significant figures or expanded notation, all that. And so, yeah, this is what we're dealing with. And I decided not to write the number again, so I just dropped down to those parentheses, moved the sign over, so it's sine -1, I forgot what that's called. And you get this small number here. And then we just decided to round that to 5. So the angle of which we need to place our blaster to get a semi-accurate hit on the target is going to be about 5 angles. So we're going to do that and see how it goes. Our previous equation, we have 5 degrees rounded. On the protractor, I marked it with a marker. Yeah. And we're going to stick the gun here and kind of measure it out to see what 5 angles would look like with this. So, or 5 degrees, not angles. And it's going to be right about there. So the gun's a little bit tilted. And we're going to start firing, and hopefully we'll get a better, better accuracy on the darts. However, come back over here. However, Samuel says that these darts are pretty inaccurate. And that makes sense because one of them actually went higher than the bullseye, which is higher than where this gun was at. So they are somewhat crazy, but most of them hit the ground in front of the tile area. So we should be able to eliminate at least some of that problem with the 5 degrees. So we're going to zoom in, and here we go. Okay. Whoa. Holy cow. Okay, well, something went wrong there. Literally every single one of the bullets went higher than the target. Maybe something with the flywheels, which is the thing that shoots the darts, was, I don't know, different somehow. But with a normal gun, with no changes, forgot what the thing is in science. No variables. There we go. Without any variables, that should have worked. So, yeah. Thanks for watching, and see you next time. Peace.